My name is Miles Brown. I'm an AWS authorized instructor, and I've been teaching AWS authorized training classes for about 6.5 years. And, when we say AWS authorized, what we mean is that AWS builds the content. They have a training and certification group that builds the curriculum, builds the lab environments, and then they push that out to authorized training providers. And, certainly we'll talk a little bit at the end about some of those courses. But today we're sort of starting very low level, just sort of saying, what if you're brand new to AWS and you just want to get the idea of, what are sort of the big reasons that people move to the cloud, and what are the main kind of services, the foundational services that everybody uses, and then, where to learn more afterwards. And so that's basically what the agenda is going to look like. We're going to start with some cloud definitions and some really high level, why do we want cloud and why do we want AWS? And then we'll get into the foundational services. I'll do a quick little demo along the way, and then we'll end on, sort of where to learn more. So the cloud definitions, we're going to start with just a simple definition of cloud computing. This one comes from NIST, but there's a lot of definitions of cloud computing, but mostly they revolve around this idea of there's on-demand provisioning of a shared pool of resources. And the resources are the things that we would normally see in an on-prem data center. So we're talking about, we need some servers, we need compute, we need networking, we need storage, So we want to be able to rapidly provision that and release it when we don't want. And we don't want to pay for things that are sitting there idle a long time. That's one of the big benefits of the cloud, is the elasticity. When we're busy, we can provision more resources and scale out. And then when we're less busy, we can scale in. We can turn things off and stop paying for them. And when we do this, there should be minimal management effort involved. Right? I should be able to, basically build some automation to grow and shrink a cluster of, say, web servers or something. But also, when I want to provision a machine, it's not like the old days where you have to, create a PO, go and send that off. Somebody ships you hardware. You have to unbox the hardware, plug it in, maybe install stuff on it, right? We don't want those, those things that take months to do, right? When we're talking about virtual machines, we can launch them, and it takes maybe 2-3 minutes to launch, and then we can shut them down and stop paying for them whenever we want. And so that's some of the big ideas behind the cloud. And like I said, the resources that we're trying to provision are the same kinds of things that you would see in an on-prem data center. So we're talking about compute and networking, storage, and then, all the things built on top of that, databases, application services, all those things. So if we look specifically at the benefits of cloud versus on-prem, when you look at on-prem, you've got this idea of, well, first off, we need to get a data center. So I either need to buy land or lease land and build a building or lease a building, something. And then we have to fill it with a bunch of big, racks full of servers, right? And we have all the people involved in buying those, shipping those, unboxing them, plugging them in, and then the labor that goes into really just managing those physical devices and applying patches and all that kind of thing. So if we look at these first two bullets, well, what do we do in the cloud? There's no upfront investment. So we don't spend $1 million building a data center. Instead, we pay a monthly fee. And this is really attractive for, say, startups. If we look back, AWS came back in 2006. Actually, there was a few services that existed even before that. But really, when they started, they really targeted startup companies because, if you're a startup and you get seed money, you don't want to blow it building data centers around the world and having, to spend all that money up front. You'd rather pay a small monthly fee. And then as your IT needs grow, so does that monthly fee. Right? And so it's all part of this idea where we're trading the capital expenditure for a monthly operating expense. So even if you weren't to save money, that is still very attractive to, say, your CFO. Right? The other thing that we have to do a lot of is the basic maintenance of the system administration kind of thing, where you're always you need Linux administrators and Windows administrators and actually people who maintain the physical devices and all that kind of stuff. And so you are in the data center business if you've got data centers. In the cloud, you're basically saying, I don't want to be in the data center business, right? That's not what makes my company different than somebody else's company. Instead, I want to focus on the innovation and focus on what we're good at, right? So stop spending time and money on the things that were not our core business, right? Now, I mentioned that, even just trading that CapEx for OpEx, that'll make your CFO happy, even if you weren't to save money. But chances are you are going to save money, right? Because when you buy hardware in a data center, you buy a bunch of hardware, you probably don't need it all. Like I think about the old days when I said, hey, I need 5 web servers, and you went and bought 5 physical machines, plugged them in. The chances of all 5 running at a high utilization rate at any given time is pretty low. So you're buying all this hardware up front, you plug it in, it's sucking power, it's heating up your data center, so you got to cool it, right? And so you're spending a lot of money just for these things to sit idle. And you've got this fixed capacity. And then every once in a while, as my IT needs grow, I go and buy another huge purchase and install a bunch more stuff. In the cloud, it's very flexible because, like we said, we can quickly, provision more stuff and quickly get rid of it. And so all of that procurement and setup and getting that fixed capacity, we trade all that for flexible capacity. And not only can we grow over time, even within a single day, we could say, hey, we're busy in the middle of the day, not so much in the middle of the night. We can provision stuff and then get rid of it. And also that idea that I can provision something, if I don't like it, if I got something wrong, I can get rid of it later, right? And when you think about that agility that gives your IT group. I know a lot of times when people talk about the cloud benefits, they focus on the money, right? Because it often comes from the CFO or the CTO down saying, hey, we're going to save money if we move to the cloud. But what I find is, a side benefit, a huge side benefit, is the agility it gives you. Because you don't pay for stuff you don't want running anymore. You just shut it off and you stop paying for it. And what that does is it lets you, if you can put the keys to the kingdom in your developer's hands and they say, hey, I can go try something out. If it doesn't work, get rid of it. Right? What's the cost of failure? It's very low. If I'm renting these virtual machines for pennies an hour, I try something out. If it doesn't work, I turn it off. And what that means is when the cost of failure is low, I can experiment more. And you get this sort of culture of innovation that generates. And so that's sort of another big benefit. Oops, there it is. So like I said, when the cost of failure is low, this generates a culture of innovation. And then finally, if you look at building data centers, often, companies will start with one and then they decide for high availability purposes, they'll build more data centers further away. And that gets hard to negotiate, how do we keep these databases in sync across, large geographic distances. Well, if you want to build data centers around the world, that's costly, it takes a lot of time. But when you get into the cloud, AWS has data centers all around the world already. So the first day when you go and set up your first AWS account, you could launch things in any of these regions around the world. And we'll see what those regions are. Now, I mentioned that flexible capacity. In general, most people's IT needs grow over time. Nobody has less data than they had 5 years ago, right? But in the on-prem world, we're buying both storage and compute power servers, in chunks, right? You buy some, and then when you start to hit the limits of that, you buy more. Right? Unfortunately, the demand curve isn't a straight linear line like this. It's a lot more interesting, right? The actual demand for your IT needs, you might look and say, well, hey, if you got a retail website, you look in November and it's sort of flat, and then all of a sudden it's Black Friday and Cyber Monday, and all of a sudden your IT needs are really high, and then maybe they go down again. But over time, it will eventually grow. Right? And what the problem is here with the way we purchase traditional hardware, there's sort of two problems. At one point, you might say, well, I went and bought a bunch of hardware for the next, couple of years, and I've got way too much that I'm, remember paying to power and to cool in my data centers. So that's money I could have spent somewhere else. The much bigger problem is when we temporarily have more demand than we actually have resources for, and, you're probably leaving some customers unhappy. And so what we try and do in the cloud is we react quickly as we can. We can actually look at metrics. We can say, hey, I got this fleet of web servers. When the CPU utilization goes over 65%, let's add 2 more servers. And then we'll do it again. We'll do it again. And then at some point in the middle of the day, we're pretty busy. And then all of a sudden, the traffic starts to dwindle. And so we set another alarm that says, hey, when the average CPU goes under 20%, let's remove a couple of servers. And so by doing that kind of dynamic scaling, what we can do is we can match our provision capacity, as closely as possible that we do to the demand curve, right? And so that's where you're really going to start to save money, is when you start to embrace the cloud like that. Now, a little more terminology. You may have heard of these terms: infrastructure as a service, platform as a service, software as a service. What we're really talking about is how much am I depending on the cloud vendor to do versus how much is my responsibility, right? So if you think about, something like running an Oracle database or something like that, in an on-prem environment, you're managing everything, right? You run the data center, so you got to set up the networking, and you got to get racks of servers, you got to have storage, and then you install, operating system and my application, my database, everything is on top of that. And so you have to manage everything. When you move to the cloud, typically what you're doing is you're renting virtual machines, and by the hour or by the second, depends what kind it is, but, typically they'll advertise an hourly rate. And so what you're getting is you're saying, I'm going to basically trust that Amazon or some other cloud vendor, could be Microsoft Azure, could be Google Cloud. AWS is definitely the biggest of the big 3 public cloud providers. But typically what you're doing is you're saying, I'm going to let them take care of the physical machines and the networking environment, the basic networking environment. And what I'm going to get is an operating system installed. So I launch a virtual machine, and it's either some flavor of Windows or some flavor of Linux comes up. And then I'm in charge of that OS. I have to manage it. I have to patch it. When there's patches to come, I need to harden it, shut down the services I don't want, and then install whatever I want running on it. But they call that infrastructure as a service, right? The next level is where you say, I want to rely on my cloud vendor to do even more. Right? And maybe they can manage even the operating system and install software on there for me. So we'll look at some examples of PaaS. Sometimes they shorten it. They call platform as a service PaaS. Software as a service, you probably understand that one. Things like Salesforce.com, Gmail, all those kinds of things where, I don't think about the servers at all. It's all managed by somebody else, and I'm maybe configuring how it works in a UI. If you think about public cloud providers like AWS, they really focus on the infrastructure as a service and the platform as a service. They sometimes have software as a service. So Amazon, if you look in the AWS console, there is something called Workmail and WorkDocs and QuickSight. So Workmail is a lot like Gmail. WorkDocs is, like shared document stuff. QuickSight is a little bit like, it's a business intelligence, a BI tool like Tableau. Actually, it looks a lot like Tableau. Right, so they have a few of those, but that's not really their bread and butter, right? When you think about AWS, you're normally thinking infrastructure as a service or platform as a service. So let's take an example of a platform as a service. I mentioned earlier, running an Oracle database or something like that. Well, instead of manually installing and managing that database software on virtual machines, which is the infrastructure as a service, what this RDS service that Amazon provides, called Relational Database Service, it provides a managed relational database. And there's 6 different options for, what kind of database is it, what engine is running. So they picked the 2 most popular commercial databases, Oracle and SQL Server, and the 2 most popular open source, MySQL and Postgres. Then eventually they added support for MariaDB, which is kind of forked off of MySQL. And then they built their own called Aurora. So now you have 6 choices of engine. And the idea is, I'm no longer the DBA. It's a huge trade-off. I'm saying I'm going to let a brainless algorithm at Amazon be my DBA. And now what do I get? I get a JDBC or an ODBC driver. I can connect, but I don't have to think about the virtual machines, the operating system, the file system. In fact, I don't have any visibility into that at all. Right? I'm a user of this database. Now, I can go and set up my tables and decide where indexes and partitioning and all that stuff goes. Right? So it's quite a bit of a trade-off, right? And what we're allowing Amazon to do is take care of the undifferentiated heavy lifting. That's a term that the chief technical officer, Werner Vogels, he's the chief CTO at Amazon.com. He coined this term. He said it's the same work that we all have to do. It's no different in my company than your company, the basics of setting up something like an Oracle database, right? And so if you think about the responsibilities of running a database in the infrastructure as a service, if I do it in my on-prem, I have to do everything. But if I go to infrastructure as a service, basically Amazon takes care of, the hardware, the virtualization. They will install the operating system, but it's on me to patch it, install the database, patch that, set up nightly backups. If I don't want this database to be a single point of failure, I'll have to set up some sort of synchronous replication to a second database, right? And so this is basically if I want to host my database on our virtual machines. In AWS, a virtual machine is called an EC2 instance. So for the rest of this, if you hear me say EC2 or say instance, think virtual machine. Now, if you go to Google Cloud or Microsoft Azure, they just call them VMs. In AWS, we call them EC2 instances. But under the covers, that's what they are. It's a VM. And so the idea of going to PaaS instead of infrastructure as a service just says, I'm going to now rely on AWS to do more. They're going to take care of all those basic DBA duties, including the installation, the patching for maintenance, the database. They'll set up nightly backups. I get to choose when to take the backup. They'll actually do all that maintenance on a schedule. I get to tell them when is the best time during my week to do maintenance. Okay? So that's the idea. And all I'm left with is, hey, what should my app look like? In addition to these infrastructure, platform, and software as a service, the sort of newest model is called function as a service. Right? Some people call it FaaS. Mostly people talk about it being serverless compute. Right? And in AWS, the main service we have for this is called Lambda. And it's very developer-centric. If I'm a developer, I develop Java or .NET or Python or whatever. I write the code, and I don't want to have to worry about servers, operating systems, making sure that there's redundancy for high availability, making sure that things get deployed to the right way. All I want to do is say, here's my code, and I want to configure what's the event that causes that code to run. And that's the idea here. It's really event-based. Now, the event might be somebody uploaded a file to my cloud storage. That should kick off this code to run. And instead of paying for a virtual machine, so many cents per hour, 24/7, to run this application that just sort of polls once in a while to see. Instead, I don't pay at all until the event occurs and my code runs. And I pay in 100 millisecond increments for, how long did it run for. Okay? So it's a very interesting idea. And it really gets you to the point where you say, hey, if I build my sort of front end using certain managed services, PaaS offerings, and then I put my business logic in a bunch of little microservices implemented as Lambda functions, and then I use RDS or some managed NoSQL database in the back end, all of a sudden you're getting to the point where you say, across this whole stack of stuff I have, where's Linux? Where's Windows? And the fact of the matter is, maybe we don't need that. Right? Now, it's an interesting trade-off. Not everybody loves it, but there are enough people that this is their real focus for how they're going to build new cloud-first applications. Now, you're not going to use a lot of Lambda functions if you're taking an existing app and moving it to the cloud, right? What we call the lift and shift. Usually, you're just going to run that on EC2 instances, and it looks largely like the same kind of deployment and administration we've always done. Now, I've used a couple of terms here. We should probably knock off a little bit more terminology on the global infrastructure that Amazon has. You can imagine they got data centers around the world. Typically, when Amazon builds data centers, they build a cluster of 3 or 4 data centers right beside each other, and then miles down the road, another cluster of data centers. And so that cluster of data centers is called an availability zone, or AZ. Okay? And basically, they always build these at least 2 or 3 AZs together. They make what they call a region. Right? And if you look, there's 24 regions currently around the world with a total of 76 availability zones. And the thinking is, we have this cluster of data centers. Well, what if there's some local disaster that takes out that cluster? Right? We could have some kind of problem, the classic, somebody's digging next door with a backhoe and pulls out all our cables out of the wall, right? Well, Amazon says we should be able to handle that, right? Because what we're going to do is we're going to make sure whatever we run runs across multiple AZs. So when they build these availability zones, they build them close enough together that Amazon can build very low latency, very high throughput lines between them. So we're talking about just a few miles apart, right? So if you go down to Northern Virginia, that's our oldest and biggest region. Sort of outside of Washington, D.C., sort of near Dulles Airport, there's all these towns. And in one town, there might be an availability zone, and then a couple towns over, there's another availability zone. So close enough that Amazon can put very low latency links between them, but far enough apart that if there's some sort of local disaster, it might take out one of these, but not another set of data centers miles away. So anything they can do to make them independently available, they'll do. Right? What we're talking about is, put them in different floodplains, on different sides of fault lines, even try and attach them to different electricity grids if possible. Anything they can do. They're going to definitely have separate, generators and everything else. Now, when we talk about the global infrastructure, we got to kind of link back to the web page, because as soon as I make one of these slides, it's usually out of date because they're adding infrastructure all the time. Oh, no, it looks like I'm still good. 24 launch regions and then 3 announced coming soon ones. Oh, there's now 77 availability zones. And in fact, if I go and click on here, they have a nice little interactive globe that you can look at, and you can say, oh, here in North America, we've got 7 regions. So there's 6 in the U.S. and 1 in Canada. Now, 2 of the regions in the U.S. are special ones. You see there's a GovCloud West and a GovCloud East. Those ones you can't use right out of the box. So out of these 24 regions, there's 4 special ones. These 2 GovCloud and then the 2 in China. You basically have to fill out a form, and they do a background check. So for the GovCloud, you have to either be a U.S. citizen or a green card holder, because what they try and do is lock that down. They don't want foreign nationals in there. And they also, with those regions, they don't have all the services available, only the ones that have been vetted heavily so that you can get FedRAMP and even ITAR compliance. So if you have to do something with the Department of Defense and you need to get ITAR compliance, well, then I'm going to want to run in the GovCloud. The China region, they basically do a background check to say how and why you're doing business in China. But other than those 4, when I set up my account, which really just requires a valid credit card, an email address, and then you give them a password, that first day you can go and launch things in any region. Now, typically, how do people pick a region? Well, usually it's got maybe there's data sovereignty laws at play, right? So I've got this data that cannot be stored outside the U.S., so I have to use one of these 6 regions. Right? Then it becomes, well, maybe we look at the latency. Most of my customers are on the East Coast, so I'm probably going to want to run my web servers as close to them as possible. Or maybe my data centers are here in Palo Alto, so I want to use the region closest so that it's very fast to move data back and forth between the cloud and my data center. Right? So, there could be latency. And then the other thing is not every region has every service. So you have to make sure you pick a region that has the services you need. And there are even price differences. In the US, most of them are priced the same. Actually, the Northern California one's a little more expensive. You can imagine running a data center in Palo Alto is a lot more expensive than in the middle of nowhere in Oregon, right? Real estate's different, labor's different, probably electricity costs are different, so there are some differences there. In addition to these regions, you'll see these little pink dots all over the place. There's over 200 of these, what they call edge locations. And those are places where you can run certain services that need proximity to the customer, right? So one example is we have a service called Route 53, which does DNS hosting. So I need this network of DNS servers all around the world, so no matter where somebody is, if they're trying to find, milesbrown.com, they can quickly find a nearby DNS server that will tell me, oh, it's this IP address. So there's a few services that use those edge locations around the world. All right, so that sort of knocks off the basic terminology that we wanted to get through. Oh, by the way, if there's questions at any point, you can use the chat functionality, throw them in there. I've got my eye on it once in a while. I'm trying to keep current with the chat. So let's jump in and talk about some of the foundational services. Actually, first, let me just show you. This is what the AWS Management Console looks like. So like I said, you just need a valid credit card and an email address. You go set up an account, and they will give you some stuff free for the first 12 months, but it's not like a separate account. If you look at the AWS competitors like Azure and Google Cloud, they have a separate kind of free tier account, it's called, where they're never going to charge you a credit card, but it's really limited in what you can do. In AWS, there isn't a separate kind of account. It's a basic account, a regular account, but if you do certain things, they won't charge you, right? So it's really buyer beware. You got to make sure you know what you're doing. And I can only imagine when somebody starts today and says, hey, I want to learn AWS. They go sign up for an account, and then they look at this list of services. Let me scroll kind of slowly through it. There's over 170 services in this list, and it must be very daunting. I know there wasn't when I started, right? So 9-10 years ago, when I first got into AWS and I got into the Management Console, there was about 8 things in the list. So learning all of AWS wasn't terribly difficult then. But now what you find is that there's been this explosion of features and services, but a lot of them are very niche, right? So if you look here, they got something called the ground station. When I hover over it, the tagline says, communicate with satellites. Well, not a lot of people have to do that, right? So I'm never going to learn anything about that other than that's what it's about, right? So out of this list of 170, there's about a dozen services that you really do need to know, because everybody uses them, right? And so let's just do a quick survey of those. The most fundamental of all the services is EC2, right? That's our virtual machines. So that's how we get compute for the infrastructure as a service, right? If you think about other services that offer compute, we did talk about AWS Lambda already, right? That's a way of doing serverless compute where I don't think about, hey, I need to launch a Linux server and manage that operating system and set up a file system and all that. I don't think about that at all. I mean, certainly there is all that somewhere, but Amazon's taking care of it. I'm just saying, here's my code, here's the event that causes it to fire. Now, in the old days, say 13, 14 years ago, actually more than that, even 15 years ago, when you launched an EC2 instance, when it came to networking, they asked you one question. Do you want this to be a public IP address or just have a private IP address? They always get a private IP, but do you want a public IP? And so if you were launching something like a web server that needed to be accessible from the internet, you said, yes, give me a public IP. Otherwise, you didn't get a public IP. And so, if I was going to launch a database or something, I would just say, no, it can only be accessible from other things in the cloud. Well, eventually people wanted to be able to think of the cloud as like an extension of their own data center, right? Where they want to be able to set up a VPN connection from their data center and talk to things in the cloud, but not go through the public internet and maybe not make things accessible to anybody in the internet. Well, in order to do that, they said, well, we got a bit of a problem. Right now, Amazon decides and just randomly gives you public and private IP addresses, whichever you need. So how do we know there's not going to be a conflict if we're networking back to your own data center? They said, we're going to have to change this altogether. And so what they did was they introduced a service called VPC, Virtual Private Cloud. And the thinking was, let's give you, the customer, and more specifically your networking people, right, total control over this slice of Amazon's network. So I create a VPC. When I create it, I tell them, what's the IP address range of the private IPs that will be used, right? And so typically people will use one of those IP address ranges that's reserved for private networking. So I have this data center, it's 10.1.something.something. This data center is 10.2. And then I make a VPC, it's 10.3. And what that means is anything that gets launched into that VPC, and so when I launch an EC2 instance, I have to launch it into a VPC. It's going to get a private IP address, 10.3.something.something. And so now I know there's not going to be any collisions. And then I take my VPC and I cut it up into subnets and decide about rules of what traffic's allowed in and out. And, we got lots of good networking stuff. I know a lot of you might be networking people. When you see what's available there with the network access control lists and various kinds of software firewalls that we have. Of course, everything, we do in AWS is software configured, right? So even the things that we have like load balancers and gateways and everything, there might be some physical hardware going on in Amazon's data center, but we don't have any say over it. Everything we do is software-defined networking, okay? Including a load balancer. So they make it a nice load balancing service to make it very easy to say, hey, I've got this cluster, I've got a fleet of 10 web servers, I want a load balancer in front of it. So instead of me having to launch an EC2 instance and install some software load balancer, right, which is a single point of failure, and then you say, okay, well, I guess I better launch several, have them heartbeat into one another or whatever. Amazon said, don't worry about it. We'll make a nice service. You just say create an ELB. We'll take care of making sure it's highly available and scalable and everything under the covers. When it comes to storage, certain EC2 instance types, that's a virtual machine that's running on some hardware. That hardware might have disk. So we're talking about direct attached storage. We call that instance storage, and not every EC2 instance type comes with it. Actually, most of them don't. Right? The real problem with it, it's fast. It's really cheap. Like basically, it comes for free with the hourly rate that you pay for your EC2 instance, but it's not persistent. So if you stop or terminate your virtual machine, or the virtual machine just dies, however it gets decoupled from that physical server, we're going to lose all the disk there, right? So it's ephemeral storage. And so if we want regular kind of block storage, like a regular disk drive stuff, that's what we use EBS. It's called elastic block storage. So you're going to go and say, hey, I want to provision a 10 terabyte drive, and you start paying for it right away. And then you can attach it to an EC2 instance, and it's usable from that one instance until at some point I can detach it and attach it somewhere else, just like I can take the disk drive out of my machine and attach it somewhere on other machine. Or at some point I can just delete it. Okay? So when you attach an EBS volume, it just looks like an unformatted DIM. You format it, put some file system on it, and then you use it like a regular disk drive. So that's what EBS is like. And then we have this sort of really foreign concept. There's not really an equivalent in most data centers of S3. S3 stands for Simple Storage Service. And instead of being like a block level kind of file storage, they call it object storage. And sometimes people refer to it as internet storage because the way we access it is through HTTP or HTTPS, and you do gets and puts and deletes. And so basically, I set up the top level namespace is called a bucket. I set up an S3 bucket, and I get basically a URL, right? And I use that URL from anywhere on Earth with the right permissions to put and get objects out of that bucket. What's an object? Well, it's a file, any kind of file you want, right? Now, these are some of the foundational services. If we go a little bit further around security, we have to keep track. Everything we do in AWS at some low level is an API call, right? And at some low level, it's actually a RESTful web service call. That's why it's called Amazon Web Services. But, we can use, say, the management console and click, click, click and do stuff. And I'll do that coming up. Or I can do the equivalent stuff. Anything I can do in this management console, I can use a command line tool to do the same. Right? So they have a nice little CLI, it's called the command line interface, that you can install in Windows or Linux or Mac. And basically you can build scripts, shell scripts or PowerShell in Windows that uses that API to do the same stuff that you would do through the management console. Or you could do it programmatically. There's an SDK in Java and Python and C# and C++ and, about a dozen different languages. Right? So we have lots of different ways, but at some low level, they're all accessing the same RESTful web service. And so you have to decide who's allowed to make which calls. That's important because everything, setting up the network, launching virtual machines, accessing a NoSQL database, all those things are API calls. And so identity and access management, IAM, is where you set up users and groups and dole out permissions to say, allow or deny which API calls on which resources. Now, the other part of security, there's lots of other security services, but another major one is called KMS. And so this is a service that basically what we use for encryption at rest. So there's lots of different places where we store data. We may want to encrypt that data at rest. So we need to keep track of the data keys and then encrypt those data keys. So it's sort of like a multi-layer kind of a envelope encryption. And so instead of me having to manage the infrastructure to keep track of all the keys I'm using for encryption, that's what KMS does. Now, we've already talked about RDS, the relational database service. That's a PaaS service for running one of those 6 database engines. We have another relational database called Amazon Redshift. It's more of like a data warehouse. It's very much a competitor of, say, Teradata or IBM Netezza or Oracle Exadata, something like that. Then we have DynamoDB, which is a fully managed NoSQL database. Actually, there's a whole bunch of NoSQL database options. Right? And in fact, when I think about NoSQL databases, it's really an umbrella term. There's a lot of different kinds of NoSQL databases. But I remember about 9 years ago, I was using MongoDB. We weren't using it. I was in a place where we mostly did MySQL. But I had this application where I was storing JSON files and loading them back in, and I was using NoSQL, and I was forever converting JSON into sort of a result set and then back. And I said, I bet this would be perfect for MongoDB, but we didn't have a lot of expertise. And at that point, trying to get together 3 or 4 Linux boxes in that company to try something out was like pulling teeth. Right? And then once I did get some to try something out, then I had to become an expert in, how do I install and configure MongoDB? And I'm really more of a developer than an administrator, right? But somebody had to do all that. When I first started using DynamoDB, I didn't really need to know much about it. I just came in and I said, hey, they've got a NoSQL database. I'm just going to say create a table, told them what the primary key was. That's it. The table's up and running, right? And it'll grow unbounded, right? I could have billions of rows and I don't have to worry about the infrastructure because it's a fully managed database. So that's some of the real benefits. What it really did was it said, hey, when you move to the cloud and you want to embrace new technologies like machine learning or NoSQL databases, or, the list grows and grows, you don't have to know everything to go in and provision and figure out how to store it and everything else. They really democratize these new technologies and let anybody get in there and start using it. And if it doesn't work out, you turn it off. What'd you pay? Not much. Right? So this is sort of the idea. Now, I was going to do a quick little demo, so let me do that. I'm going to bring up my my management console. Where'd it go? Here it is. And so they basically have this list of over 170 services. I'm going to click on EC2, and that'll take me to a specific console just for that service. And they typically start with a dashboard where they say what's running. And I don't have anything running, at least not in this Oregon. Oregon is one of our many regions, but I can flip to any of these other ones. But I don't have anything running here. I have a bunch of security groups, but they don't cost any money, so I just never clean them up. What is a security group? It's a software firewall. So whenever I launch a virtual machine, an EC2 instance, I have to launch it into at least one security group and say, hey, what ports do I want to open for traffic from where? By default, it doesn't allow any ingress. It only allows egress. So you have to go through and pick and allow certain ports to be open. So actually, let's take a look at it. So I don't have anything running. The easiest way to fix that is the big blue Launch Instance button. What this does, it takes me to a 7-page wizard where they ask me a bunch of questions, and it culminates in launching a database. So the first thing they have to do is decide which region. So I'm already in the Oregon region, so that's chosen. The next step is to choose sort of the beginning template. What's going to be installed when this virtual machine comes up? And that's based on an AMI, an Amazon Machine Image. Now, I can build my own AMIs. I'm going to start with the quick start ones. These are basically just an OS. It just comes up and it has either some flavor of Linux or some flavor of Windows installed. And so Amazon provides a bunch of these quick start AMIs. So here you'll see a bunch of different flavors of Linux. You got RHEL, you got SUSE, you got Ubuntu, and then different versions of Windows. Windows Server 2019, 2016, 2012, whatever. So let's say I'm going to launch a Linux instance. Notice there's Amazon Linux. You probably haven't heard of that. They basically forked off of Red Hat. It looks a lot like RHEL, but you're not paying for the Red Hat license. Instead, you get support from Amazon. So these ends up being the cheapest of all the options because the hourly rate, depends on the OS because you're basically paying for the operating system license. So Windows costs the most, then Red Hat, then Amazon Linux. So let me pick Amazon Linux. And next step, it says choose an instance type. So this is a lot like if you were going to go buy hardware. It's a trade-off of cost versus how much CPU, how much RAM, how much storage, what kind of networking capabilities do they have. Now, they don't show you cost on here. You have to look on a separate screen for that. But they'll show you everything else in here. And what you'll see is that the instance types, they've got a bunch already built that are sort of grouped together in families. So here's the T2 family. Within that family, they got different sizes, from the Nano up to the 2XL. The 2XL comes with 8 virtual CPU, 32 gig of RAM, and you notice that's roughly double what the 2XL, what the XL has, which is roughly double what the large has. Right? So that's the T2 family. But then there's, T3 families are the newer ones. And these are all sort of what they call general purpose. So the T families, the M families, these are all general purpose. Now, at some point, you might realize, I know what my workload is, and my workload is going to be really memory intensive. So I want to get an instance that has relatively a lot more RAM than, say, CPU, or maybe vice versa. Right? So we have different families, and so if we scroll down quite a ways, I can get to the compute optimized. So the C5, the C5D, the C5N families, these are all compute optimized, and they'll have relatively more CPU than, say, RAM. They also have GPU instances. So if you're doing any kind of graphical processing or certain types of machine learning where you might want the underlying chip to have GPU, well, then I could choose one of these. And then the memory optimized ones, the R5 families, they usually have a lot more RAM than the basic ones do. They've got some crazy ones. If I get to the really extreme ones here, the X1E 32XL, look how much RAM this comes with. That's 4 terabytes of RAM. Not 4 gig, 4 terabytes of RAM. So you can imagine this is a big, huge machine, right? Now, the cost of that is going to be quite a bit more. So this thing costs something like $26 an hour, whereas the T2 Nano costs half a cent an hour, So there's a wide range because what Amazon has in mind is basically they want to run any kind of workload you can think of. As long as it runs on Linux or Windows, it should be able to run in AWS. So what do I need 4 terabytes of RAM for? Well, if you're running some sort of massive in-memory analytics framework like SAP HANA or something like that, then I might need this. Okay. So I'm not going to use any of those. Notice here's the one that's marked free tier eligible. Right? So you get up to 750 hours of either Linux or Windows per month for free, but only on the T2 Micro, which only has 1 gig of RAM, 1 virtual CPU. You're not going to run production workloads on that. It's a very small server, but it's good for proof of concept, for learning, things like that. So let me pick one that does come with a little bit of storage. Notice most of them don't come with any instance storage. They all just say EBS only. But I'll pick one that comes with a little bit of storage. So here we go. We've got this one, 175 gig SSD drive. So that's that ephemeral storage. That's the direct attached storage. My virtual machine is sitting right there, and it's using the disk on that server. All right, so I'm going to pick that. Next, it's going to ask me a bunch of questions to configure it. How many do I want to run? Which network? Now, I haven't done anything with networking, so I'll just use the default VPC. Now, one thing I could do is I could just launch it, and then I could SSH in, right? If it's a Linux box, I can SSH in. If it's a Windows box, I can RDP in, right? And then I could run a bunch of scripts or whatever. The other thing I could do is actually provide a script right here. I write a little script. If it starts with the right key sequence, so here it's hash bang, hash bang, and I'm going to say let's run a little bash script that basically does a yum install of the Apache web server, and then starts that service HTTP daemon start. Now this isn't going to be a very interesting web page. Right, because if I was really doing this, I would go and download some zipped up web application, and then maybe unzip it into the right directory and set the permissions properly, and maybe I'd have to also install PHP or MySQL or whatever. So here, I'm just going to install Apache, and I'll get the test page. Okay. Next, when it comes to storage, there's that ephemeral drive, the 75 gig drive. That's going to be there. They choose not to use that as the root volume where Linux is going to get installed because we want to be able to stop and restart and not lose that data. So we're going to use an 8 gig EBS volume for that. I can go add other EBS volumes here, a little 10 gig drive. I could decide whether or not these other drives, they can have a lifespan separate from this EC2 instance. So if I stop or terminate, if I terminate the instance, I can still have my disk drive and then later attach it somewhere else. Now, the root volume, they typically will, default that to delete on termination. So if you were running Windows, that root volume is basically your C drive where Windows is installed. If I say get rid of this server, I don't want to keep paying for that disk drive floating around out there. Next, you can add tags. Tags are basically a case-sensitive key-value pair. They're kind of meaningless unless you put some meaning on them. They suggest that you should have a name tag. Okay, so this is, I'll call it web server 1. But you could do all kinds of things. I could say, what department is this for? This is for the training department. These things don't mean anything unless we put meaning on them, right? And like I said, if I don't give it a name tag, if I launch a bunch of stuff, they all have like a cryptic ID. So this is how I can sort of identify one from another. This second tag I could use, say, for billing purposes. At the end of the month, I'll typically get a bill that says, here's how much you owe for EC2. Well, now I can make a billing report that says, show how much I owe by department. Right? And then the last step, so this is step 6, step 7 is just a review. It says, hey, go and choose from a list of which security group do you want to run in. So if my networking people went and set up the rules and those software firewalls, I could do that. Otherwise, I can just create one. They recognize that, hey, this is a Linux box. You probably want to open port 22 so that you can SSH in. Now, where do you want to open to? Anywhere? Now, that's a bit of a problem. You could say, just a particular IP address or just this IP address range. Now, I am going to add so that I can do HTTP, so open port 80 to anywhere. Now, they don't warn about that. And when I go and review and launch, oh, there's one sort of warning. This is not eligible for the free tier. Oh, we knew that. Now, the problem is I didn't give them a username or password or anything. So when I go to launch, they say, wait a minute. You should have a key pair set up. And when they talk about key pair, what we're talking about is, asynchronous encryption, like public-private key. Like anything I encrypt with the public key can only be decrypted by the private and vice versa. And ideally, I've gone ahead of time and I went and generated a public-private key pair and uploaded the public key to Amazon, and I retain the private key. But I haven't done that, so I can just create a key pair on the fly. And so I'll create a key pair, and I'll just call it July 16th KP, just so I remember to get rid of it later. Won't let me launch until I download the private part. And that private part is going to be stored as a PEM file. So I'll just store that on my machine. And the public key gets uploaded to Amazon. And so basically they're going to, when they launch that Linux virtual machine, they're going to go and create a user called EC2-user. And they're going to add that user, they're going to add that public key to their keys. So that if I want to SSH in, I need to use this private key to do so. So I tell it to launch the instance, and if I scroll down, it says View Instances. I'll see here it's yellow. It says it's pending. So they do show me the name tag. So Web Server 1, there's that cryptic ID. It's an M5AD large and US West 2D. So US West 2 is the availabilities, or is the region, and then the letters A, B, C, D. Those are which availability zone within that region. Now it looks like it's going to, kind of. This thing's spinning, you got an hourglass here. I don't wait for it to refresh. I hit the refresh button up here, and I say, oh, okay, the instant state is now running. That means the virtual machine's up and running. Doesn't mean it's totally ready to go. So there's a couple of status checks that you should wait for. Once it says 2 out of 2 checks have passed, that means it's up and running. It's got network capable, it's good to go. But in the meantime, if I did want to SSH in, I could go to Connect, and it says, I hope you have an SSH client. Now I'm on my Mac, so I could just bring up a terminal window and tell it to SSH in. And I just need to know where is that PEM file on my disk drive. I saved it somewhere. And here's the EC2 user at, and then either the public IP or the DNS name of the server I'm trying to get into. But I'm not going to do that, actually. All I need is the DNS server or the public IP, and I'm going to open that up in a browser and see if that works. There we go. I got a test page. So it took me, 2 minutes to go and launch? Maybe 3 minutes to go and launch a web server. Now, it's not a terribly interesting web server. I only got one test page in there. But, it works. And if I go back and I look and I say, hey, let's view, there's the Launch Wizard 22, my security group. If I view the inbound rules, if I wanted to, I could come back in here and let's say, let's go change those inbound rules. Let's edit this, and let me get rid of the HTTP ones. Now I go back in here, and I try and reload this page, and I think you can see it's just kind of bouncing, and eventually it'll time out because that port's not open, and it can't get in there. All right, so just to finish up, where to learn more. So I'll talk a little bit about the training and certification. AWS has basically 4 levels of certifications. They're all achieved through multiple choice exams. You can either go to the test centers when they're open. Right now they're not open, but Pearson VUE now allows online proctored exams. So all the AWS exams are available online. You just have to have a webcam. Used to be they just had the associate and the professional level, right? But they added this foundational level. It's really pretty simple certification to achieve. It basically asks the question, do you know how to spell AWS? If so, congrats, you're certified. I don't know how useful it is. I know that we usually get people who are like project managers or salespeople, not technical people. And they just want to show, hey, I have some familiarity with AWS, the main services. So that's what the cloud practitioner is. Most people that come to our technical classes skip that and they go straight to one of the associate level ones. And so they have them by 3 different paths: architects, operations, or developer. A lot of times people think, I'm a developer, I should take the developer one. By far, the architect is the most popular. It does the best job of making sure you have broad knowledge of AWS. The operations one would be more for, system operators, administrators, network administrators, people like that. in the labs, there's a class that goes along with those certifications. So we have three-day classes for the associate levels, and the SysOps class, you're going to do a lot more of the command line and building scripts. In the developer, you're going to be actually using the SDK in Python or Java or C#. In the architect, everything's done through the management console. And then we have a professional level architect or DevOps engineer. You don't need to do the associate before you go for the professional, but you better have the knowledge. The professional and these new specialty ones are all much more difficult to achieve, but they're also more prized in the industry. Right? The specialty ones, you got machine learning, data analytics, database, security, right? There are basically 3-day classes or maybe a 4-day class for the machine learning that kind of correspond to most of these. Right? These courses, I'll just run through this list and then we'll break for questions. The technical essentials is a 1-day class. That's usually we think of it as the first day of any of those 3-day classes. So if you're pretty new to AWS, you should probably take that. The cloud practitioner essentials is it's a little better for people who are maybe non-technical or people specifically looking to get that foundation kind of certification. The architecting is by far the most popular class. SysOps and developing, you probably wouldn't take all three. There's a lot of overlap between them. There is an advanced architecting, another 3-day class, which would kind of prepare you for the professional. Now we have this 5-day class called Architecting on AWS Accelerator. It's basically the 3-day architecting, the 3-day advanced architecting jammed together in 5 days. The other professional certification is the DevOps engineering. This one will help with that. Then we have a little more specialized ones, the database class. The big data class is really, covering services like EMR, which is our Hadoop managed service. Data warehousing is all about Redshift, which is that data warehouse service. And then this 4-day machine learning pipeline is a fairly new class for data scientists and, like I said, here would-be data scientists to get familiar with machine learning concepts, as well as the AWS tools like Amazon SageMaker. You can register for any of these classes. Go to the dwwtc.com/AWS. Here's what that website looks like.